Class Payable Interface Test is going to now use the payable hierarchy of types to demonstrate polymorphic behavior using interface type variables. So you'll see here in line 9 that we've once again created an array in our test application. This time the type of the array is type payable. Now, just like with an abstract class, you cannot create objects of an interface type directly. So here we're not creating objects of type payable, we are creating variables of type payable, each of which is initially null and will eventually be used to refer to an actual object of a class that implements the payable interface. So our payable objects array has 4 variables in it, each of which is of type payable, and we will now use those at lines 12 through 17 to initialize each of those variables or assign each of those variables an actual payable objects. So at line 12 here, for example, we create a new invoice object and assign it to the first element of our payable objects array. Now, just like we talked about in the abstract class hierarchy for class employee, this type of assignment will only work if we have the ISA relationship as we go from the right side of the assignment to the left side of the assignment. So on the right side, we have, as a result of this new operation, a new invoice object, and an invoice object is a payable object because of the fact that class invoice implements interface payable. So I can actually assign an invoice object to a payable variable, which allows me to view that invoice as generically the concept of a payable object. We do that again here at line 13 with another new invoice object being assigned to the second element of the array. Then in lines 14 and 15, we assign a new salaried employee to the third element of the array. And again, this works because a salaried employee is an employee and because all employees are payable objects. If you recall, back in class employee, we said class employee implements interface payable. So because of that, all of the subclasses inherit that ISA relationship, and I can indeed assign a new salaried employee object to a payable variable in this array, and we do that again here at lines 16 and 17. So now we have 2 invoice objects and 2 salaried employee objects inside of our array, and as we did in the prior abstract class hierarchy example, we're now going to use that interface type to iterate through a collection of payable objects and output both their string representations and their payment amounts. So if you look at this printf statement in the for loop, first of all, the for loop itself says for every payable object in the payable objects array, we're going to call that object current payable, and then we're going to output that using printf. First, at line 27, we say current payable.toString, and the compiler looks at this expression and says, for something of type current payable, can I invoke the toString method on that object? Well, let's go back for a moment and look at the payable interface. If you look at the payable interface, which is the type of that variable, you'll see that this interface only defines a method named getPaymentAmount. So how is it that we can go at line 27 in the PayableInterfaceTest class and invoke toString? Well, let's think about that for a second. First of all, we have the current payable variable of type payable according to line 23. We know that it is a non-primitive type variable, therefore it really is going to hold a reference to an object. So at runtime, current payable can either be null, in which case it doesn't refer to anything, or it's going to refer specifically to some type of object that is considered to be a payable object. And the key word in what I just said is that it's going to refer to something that is an object. In Java, you are guaranteed that a non-primitive type variable can only hold the values of null or a reference to some sort of object. And since all objects have the toString method, we are in fact, through an interface variable, able to call the methods even from class object, although they are not explicitly listed inside the interface payable type. So line 27 calls toString on whatever object this current payable variable refers to. Then separately we're going to output the payment due, and we're going to invoke current payable.getPaymentAmount to do that. So again, when the compiler looks at this, what's going to happen is it's going to determine the type of the variable current payable, which is a payable variable, and it's going to then look at the interface called payable to see if there's a get payment amount method that takes no parameters and returns a value. And when we go back over to that payable class or interface, excuse me, you'll see once again that there is indeed a get payment amount method that takes no parameters and returns a double in this case. So it's going to allow this to compile, but you'll notice in this expression there is nothing here about the concept of an invoice or of a salaried employee. So when the compiler looks at this, it's really looking at it just for what is a payable object able to do, and it is able to have its get payment amount method called. So then at runtime, as we iterate one at a time through this collection, whatever this current payable variable happens to be pointing at when we invoke get payment amount, it's going to call that class's version of the get payment amount method. So if it's an invoice, we'll call the invoice class's version of get payment amount. If it is a salaried employee, we will call the salaried employee's version of get payment amount. So when we go ahead and run this, you'll see in the output of the program that indeed we first output 2 invoice objects and then follow that with 2 salaried employee objects. So if you take a look here, you can see that we are outputting these things polymorphically, and the first 2 items that we output are in fact invoice objects. And if I scroll back up here in the main method, you can see in lines 12 and 13 the values that were used to initialize those 2 objects, and you can confirm that the values for each of them are indeed correct. And also by doing some multiplication, you can see that the payments due are also correct. Separately, we know that we initialize the last 2 elements in the array with salaried employee objects, so when you come down to the last piece of the output here, you can see that we had 2 salaried employees, John Smith and Lisa Barnes, and those do indeed match up with the salaried employee objects that we had created back in main. So what we've shown you here is that the same is-a relationship that we got from using classes in a class hierarchy also applies to using interfaces. And the thing that's one of the key things that's interesting about interfaces is the fact that you can implement as many of them as you need to. So that makes interfaces more flexible than classes. So now you're thinking, well, why would I use an interface versus a class? Well, there are some benefits and disadvantages to each concept. First of all, if it is the case that you're going to have common data and common functionality that lots of different classes need, your best bet in that case is to extend a common superclass so that you don't have to continually redefine the data and functionality in all of the different subclasses. But there are cases where a class that you need to define must inherit from some other class, and therefore you can't create another superclass for that class to inherit from. So that's a case where interfaces are more flexible because they don't have implementation details. You can implement as many of them as you need to, getting some of the benefits of what you would call multiple inheritance in other programming languages like C++, but yet because of the fact that they don't contain implementation details, you would have to define those details yourself for every class that implements the interface. So a benefit of a class is the ability to define data and functionality for manipulating that data and inherit all of those attributes and behaviors into other classes, and that would also be considered a disadvantage of interfaces because you cannot define such details in an interface. On the other hand, a disadvantage of a class is the fact that you can only extend one class at a time in Java. That's what we call single inheritance. On the other hand, with an interface, you can implement as many of them as you want, thus giving a class many different is-a relationships. So interfaces provide much more functionality, or flexibility rather, than a class does. And just as a for example, consider the concept of an operating system which needs to be able to support printing to a wide variety of different types of printers from a wide variety of applications. So for example, the folks who create Microsoft Windows, they're going to define an interface that the various printer manufacturers will implement so that the Microsoft Windows operating system can interact via that interface with each individual printer's driver, and that would enable Microsoft to ensure that they can send the bytes of information to any type of printer that implements that interface, and that way whatever printer happens to be hooked up to a given computer will be capable of responding when somebody goes into a word processor or an email program or some other application and says, I'd like to print the current document that I'm viewing. So interfaces are quite flexible for helping programmers build software objects that can then be plugged into an existing framework that already knows how to talk to objects that implement a particular interface. So that gives you kind of the plug and play software concept. You can do that with classes as well, but again, classes are not quite as flexible because of the fact that we can only extend one class at a time.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.